Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video introduces the idea of hypothesis testing and the concepts of the null and alternative hypotheses, as well as shows how to create the null and alternative hypotheses for hypothesis testing. Let's get started. So to understand this concept of hypothesis testing, we first need to know what is a hypothesis. And in statistics, a hypothesis is simply some claim about a population parameter. So that could be the proportion, it could be a mean value, it could be a standard deviation, just any property of a population. The hypothesis test then is a formal procedure that we use to test that claim or hypothesis about the population parameter. Now here in inferential statistics, which is what we're into right now, we're actually taking characteristics of a sample and using that to identify characteristics of a population. So in inferential statistics, we're only going to have two types of hypotheses. The first is the null hypothesis, and the second is the alternative hypothesis. So every hypothesis test that we have is going to have both a null hypothesis and an alternative hypothesis. You're always going to have these two. You're never going to have any others, and you're never going to have just one. It's always going to be both of them. Let's look at each of these hypotheses together one at a time. So the null hypothesis is up first, and here the null hypothesis is simply a statement that the value of a population parameter is equal to some claimed value. So we take the value from our claim and we set it equal to the population parameter from the claim, and that becomes our null hypothesis. We usually denote the null hypothesis with this designation, capital letter H and a subscript 0. This is often read H sub 0 or H0, or as I commonly refer to it, H naught. So when we're conducting our hypothesis test, we're going to assume that this null hypothesis is true. And then our procedure is going to give us a result that will lead us to one of two conclusions. We're either going to reject the null hypothesis and then by default accept the alternative, or we're going to fail to reject the null hypothesis and therefore fail to accept the alternative. So it's going to be one of these two others. Now by definition, the null hypothesis is a statement of equality. In some of the higher levels of stats, you see taking a different type of inequality sign, but for this introductory level that we're at, you're never going to see that. You're always going to see the null hypothesis with an equal sign because it is by definition a statement of equality. Then you have the alternative hypothesis, which provides an alternative to the null hypothesis. And typically we're going to denote this again with a capital letter H, but then we use either a subscript 1 or a subscript A. Both of these designations are the same. They mean the same thing. They're referring to the alternative hypothesis. And because it's providing an alternative to the null, and the null is always a statement of equality, then you're going to have a statement of inequality for your alternative hypothesis. So less than, greater than, not equal to, these are the signs that you see when you're constructing your alternative hypothesis. So typically what we find is that the claim that we're making becomes the alternative hypothesis. That's not always exactly true. There are exceptions, and we'll get to those momentarily. But as a general rule, you're going to take the claim and turn it into your alternative hypothesis. Let's look at an example to illustrate how the null and alternative hypothesis are constructed. So we've got this XORT method of gender selection, which claims to make girls more likely. So 100 couples that want the daughter, they're signing up, they're giving birth to a baby, and we find that of the 100 couples, they give birth to 58 girls. So the claim is that with the XORT method, the proportion of girls is greater than 50%. So then what are the null and alternative hypotheses that are associated with testing that claim? Well, first we're going to write the null hypothesis, which by definition is always a statement of equality. So because it's by definition a statement of equality, it's going to take the equal sign. Notice that the 50% comes from the claimed value there in the problem statement. So that's going to be that number there. The alternative hypothesis comes from the claim itself. So here we've got the proportion greater than 50%. Okay? Notice how the claim in the problem statement becomes the alternative hypothesis. The proportion is greater than 50%. Notice also how both the null and the alternative hypothesis have the same number there. So you're never going to see different numbers for the null and alternative hypotheses. They're always going to be the same number, and that number is going to be the claimed value that you see in your problem statement. Let's take a look at some examples to further understand how to construct the null and alternative hypothesis. So for each of the claims that we're going to list here, we want to express the original claim in symbolic form and then use that to help us identify the null and alternative hypotheses. So first up, we have a claim that the mean income for entry-level engineers is more than $35,500. A recent survey of 240 entry-level engineers shows a mean of $37,475. So first, let's take the original claim and put it in symbolic form. So here, that's going to be that the mean value mu is greater than 35,500. Notice the claim is not the survey. The survey is something different. Okay? That's extra information that we don't need for the purposes at hand. We're going to learn how to identify the null and alternative hypothesis. We don't need the survey for that. All we need is the claim. And the claim is that the mean income is more than 35,500. We then take those same denotations, and then we're going to put them, replace that inequality sign with an equal sign, and that's going to become our null hypothesis, because the null hypothesis, by definition, is a statement of equality. We can then take the claim and make it the alternative hypothesis. So notice how we've taken that claim and just made it the alternative hypothesis, and then the null hypothesis is simply a statement of equality. And that's really all there is to it. Now there are some exceptions to the rule, and let's take a look at those. Next up, we have a claim that 20% of adults smoke. A recent Gallup survey of 1,016 randomly selected adults showed that 21% of respondents smoke. Again, don't worry about the survey, we just want the claim. And the claim is that the proportion is going to be equal to 20%. Well, the null hypothesis is by definition a statement of equality, so we're just going to make that our null hypothesis. Well, what then do we use for the alternative hypothesis? Well, the alternative hypothesis is going to be the proportion is not equal to 20%. Because our claim has a semblance of equality to it, and equality belongs to the alternative hypothesis, okay, we can't use the claim as the alternative hypothesis. So in this case, we have to take the complement of the claim. And the complement of being equal to is being not equal to. So here we have a difference between the alternative hypothesis and the actual claim. Let's take a look at another example. Here we have the claim that the mean pulse rate in beats per minute of adult females is 76 or lower. For a random sample of 40 adult females, the mean pulse rate is 77.5 beats per minute. So here we have the mean that is less than or equal to 76. That's the claim. The null hypothesis, by definition, is a statement of equality, but because there's some semblance of equality in our claim, we can't represent that as the alternative. So we have to take the complement of the claim as our alternative hypothesis. Okay? So anytime you've got any sort of semblance of equality to your claim, you have to take the complement to make your alternative hypothesis. Otherwise, you're just going to take the claim as your alternative, and then the null will always be a statement of equality. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.